In our last video, we graphed the function y equals the absolute value of x, and we saw what it looked like. That is the first of our examples for this year of a parent function. A parent function is the simplest possible version of any type of function. And the truth is, you already know a parent function. You already know what the graph of y equals x looks like, which is the parent function for linear functions. So what we're going to do with parent functions throughout the year is sort of analyze the behavior of the very basic form of a function. We're always going to start by looking at the domain and range of a function. So for y equals x, the parent linear function, the domain is all real numbers because the graph keeps going to the left and it keeps going to the right forever. You can plug in any number into y equals x. You'll always get a result. And the range, because a linear function goes up forever and down forever, is also all numbers. And as we'll see throughout the year, for every parent function, what we're going to do is make a table of values that shows some of the key values that are in the function. There's a little bit of room for you to decide what values you want, but what I recommend for this one is go from -2 to 2. And since the function is just y equals x, that means y is going to be exactly what x is, and that's the parent table. We're going to do this for like 8 or 9 different types of functions throughout the year. They'll get a little bit more complicated as we go, but it always comes back to this same idea. For every type of function we learn about, we're going to look at the parent table, the domain and range, and the graph. See what they all look like. So now we can do that for absolute values also. So as we saw last video, the graph of y equals the absolute value of x looks like this. And we saw that the domain was all real numbers, and the range was everything from 0 to infinity. If you prefer to write it as an inequality, y is greater than or equal to 0, be my guest. And we made a table value out of that. Notice how for the parent function, I'm just going to write y equals the absolute value of x there. For more complicated functions, usually I'll just write the name of the function, like f of x or something like that. And we saw in the graph from our last video that when you plug in a number into the absolute value of x, into the parent function, the result is simply the positive version of whatever you put in, whether or not the original version, the input, was positive. As we go through the year, we'll learn some other ways to describe the parent function, but we'll save that for another unit. The point of all of this is that functions aren't just the parent functions. There are other absolute value functions besides y equals the absolute value of x. You can do an infinite number of different things to that function. And those things are what we call transformations. Let me cover up most of this. Most of what we're going to be doing this year with graphs is about figuring out what to do about transformations. So for any type of function that we will have 3 basic transformations, and we name them by letter. We have an a, which is the coefficient in front of a function, the h, which is something you're going to subtract inside of a function, and the k, which is a number you're going to add outside of the function. Just to show you what I mean, a simple example, if I were to try and graph the function y equals -3 times the absolute value of x plus 5 plus 7. The h would be -3. The y, the a would be -3. I apologize for that. The h would be -5. We'll talk more about that soon. And the k would be 7. That's what we mean by the a, h, and k. It's just picking out those numbers. This will make a lot more sense after we play around with it. So the first thing we're going to do is talk about what the h and the k do. And you should pause this video and put this into your notes. You can wait until after we explain it. But at some point, you should pause and put this into your notes. So adding or subtracting outside the absolute value, that is the k, moves the graph up or down. We call that the vertical shift. For example, the graph y equals the absolute value of x, that's our parent function, plus 2, would be a regular old absolute value graph, but shifted up 2 units. That's what we mean by a vertical shift. That's what I mean by moving the graph up or down. The addition or subtracting inside the absolute value moves the graph backwards or forwards. This is the h, and we call this the horizontal shift. Notice that adding inside the absolute value moves the graph backwards. Which sounds counterintuitive, but it's true. And subtracting inside the absolute value moves the graph forwards. So, for example, the line or the function y equals the absolute value of x minus 3 would be the absolute value graph. That's the parent function. But then shifted forwards 3 units, 2, 3. And so then the absolute value of x plus 3, if that was a plus sign, if that was a plus sign, the graph would be moved backwards 3. We will do plenty more examples with this in our lesson, so this will make more sense after we've played around with it a little bit. The last one of our transformations is called the a, that coefficient in front. Multiplying the parent function changes the graph's steepness. For example, and this multiplication is the a, and we call this the vertical stretch. So for example, if we have y equals 2 times the absolute value of x, we would take the regular absolute value graph, try to make that a little bit neater, take the regular absolute value graph, and what we would do is make it steeper. So I will do that in a different color. It would look like this. It would just be steeper. Because now the slope would be 2 and negative 2. Positive 2, slope of negative 2, as opposed to what it was before, which was a slope of 1 and negative 1. That's called the vertical stretch, and it is the a. So what we can do with all of this is put it together so we can graph a function that has all of the transformations. The process you're going to use for this every time is you are always, always, always going to start by listing the transformations that you're doing. We've got the parent function drawn already, and then we're going to list everything that happens to that parent function. Separate the vertical from the horizontal transformations. So our first transformation, we can do the horizontal shift first. The h is equal to 4, which means we move or shift to the right 4. Again, remember, the minus sign was kind of built into the transformation, which means that the x minus 4 means the h by itself is 4. So we move to the right 4. I know it's opposite. It looks like x minus 4 should be backwards 4, but it's not. It's to the right 4. So what I'm going to do is take the graph, and I'm going to move everything to the right 4 units. And then, since the a is equal to negative 4, that changes the steepness. I can say it changes the slope because absolute value graphs are straight, so I can't use the word slope here. Changes the slope to negative 4 on one side, 4 on the other. So instead of a slope of 1, I'll now have a slope where on this side it goes down 4 over 1. And on the other side, down 4 and back 1. So passing through that point. And then the last transformation is the plus 3, since the k is equal to 3. That is the vertical shift. So we move up 3. So all of my points get moved up 3. And there's our graph. I will make a slightly bigger one. And that's the finished product.